Okay, so we're back for part 3 of Lab 5, and we're going to do some kind of table calculations to clean up this appended table where we've got Orem Parks and NDVI values for 2001 and 2022 in July. You may find that actually there was some of the information that I'm asking you to do in this part of the lab already in here. I would suggest that you kind of edit and delete that so you get the full experience. And so you can, if you got a table table attribute that you don't want, you can always delete it. So for instance, we've got new shape lengths and shape areas that were calculated because we exported this to a new file. So if you don't want that, like old one that was there before, I could delete that, make this a little bit cleaner. If you don't want to have the object ID repeated so many times, we can do that as well, right? So I can delete that object ID. And so then, maybe that's, see this a little redundant. And then you can see that I've got the different mean NDVI values here. Doesn't say what year they are. I remember, and I named them appropriately to remember, but we could also add a field and kind of recalculate it. Basically, we could say, let's add a field that's NDVI 2001, and that is a float, okay? And then if I click save, that should appear right at near the end of the table. And then I could say, calculate this field, and I would base it upon the mean, but I need to get the first of those means that's coming in because that's the correct one. So I double click mean and apply, and then it's not unclear to some other user. See this 0.224393 is the correct for NDVI 2001. I wouldn't necessarily go ahead and delete this because it's clear then where did that come from? It came from here, which was a table append. And so we could do this again, and this time 2022. Again, it has to be a float because it's decimals. Save. Close that. And then run over to the edge. We'll see we have a new one. Calculate field. And go down now. It's the very last mean for that one. Okay. Run that. And then I've got those two very clear NDVIs right next to each other, so I can compare them nicely by park. Okay, so we've appended that data and we kind of cleaned up the table a little bit. You could clean up more if you don't want all these zone codes and things like that, but I'll leave it at this for now. I'm happy that it's clear over here. And I want you to make the two following new fields, and vegetation difference and park size. Vegetation difference is going to subtract these NDVIs from one another, so similar to how we did for the difference raster. Of course, we could have also gotten this value from the difference raster, but instead we're going to subtract these two here. And then we're going to do a park size so we can see another analysis comparing by the size of the parks, if that mattered in the vegetation change. Like, did small parks become greener, or did big parks become less green, etc. So we're going to make these two new fields. Be careful. Veg difference needs to be a float. Park size should be a text. Okay, so let's add field. And let's add these two fields. So we could call the first one veg diff. And that needs to be a float as decimals. Okay, save. And then I can click down here to add a new one. And this one we're calling park size. And so what I said at the beginning of this video was that you might already find these in this table. I realized that when I created this for based upon last year, the file already had some of these values. And so you're going to want to repeat this. Don't just use that data that's in there, because you need to know how to do this. Okay, so text. And you could delete the old one and then redo this just for practice. Or you can keep the old one, redo it, and you can check to see that you got the same answer. Okay, save. So now I have my two new fields. They should be unpopulated if I close this and scroll over to the far right. What is this? Okay. So we've got, our table's getting so long, it's trying to cut me off. Okay. All right, so I've got my two new fields. That was step 5. Step 6, calculate veg diff as the change. Using the field calculator within the attribute table. So we just right click, say calculate field, and we say basically scroll down, and we want to say 2022 minus, not two minuses, 2001. And so we're using basically a calculating based upon other attributes in the attribute table. And so, you can do basic math within here. There are also things where you can use these helpers, and there's other choices, right? So we're using Python 3. There's also arcade choices in here. Okay. So this is very simple, but there's a lot of little Python helpers if you needed to try to do something else. I don't know what all these mean, but you can look them up. And so don't feel limited when you are calculating new fields in your table calculator. There may be some really sophisticated ways to kind of sort through these and do algebra. Okay, so let's apply that. So we can see that most things are more green in 2022, but some are less green. Just 2 parks are less green, but most parks are more green in 2022. It could be that 2001 was a really dry year, or maybe something else is going on. Okay, so we got our vegetation difference. The next thing we want to do is calculate park size, and we're going to do that as a classification as small, medium, and large by acreage, using the following scheme. Acres less than 5 acres, we're going to call those small parks. 5 to 20 acres we'll call medium, and greater than 20 we'll call large. Okay, so how do we do that? So go into calculate field. I'm going to make this bigger now so you can see what's going on. And it says use Python 3 expression type. Scroll to something called reclassify in the helpers and double click it. It will populate as reclass exclamation field within the equals box. Okay, and change field to acres. Do this right here within that parentheses. And it should end up being like this. So let's see if we can find a reclassify. They're in alphabetical order, so that's helpful. Okay, I think I might have misspoken. Is that Python 3 or is it an arcade? Scroll down. Yeah, it's actually an arcade expression. So the lab has a typo here. It says use a Python 3 expression type. No, it's use a arcade expression type, which is what I said in the top of the lab introduction. So sorry about that. But you can see that we basically, oh wait, maybe I'm wrong. Let's go back to Python 3. Maybe I'm wrong about this. No, I don't see that right classified. Okay, so I was wrong. Go back to arcade, click in here, go to reclassify. Okay, so that sits down here. And the argument here, so this is a little different, okay. So we need to reclassify by acres. So we're gonna, I believe we need to put that into the argument. Reclassify feature acres. And so we're gonna want to kind of copy how this is set up. And then if argument equals, well, hmm, hmm. If argument equals null, let's return, or so we're gonna switch this up a bit, right? So actually I can probably, hmm. So I guess I'm worried about, is it gonna carry, I don't, yeah, so I'm reclassifying acres, and I believe that is the argument. So I don't think I need to change that. So I'm gonna say, I'm going to basically copy what I've done here. So I say if argument is none, hmm. Yeah, these are different. Actually, this is a different code block. So either they've changed this or I was supposed to use Python 3. Is there a reclass in here? Ah, okay, there it is. So in the Python 3 expression type, you have to change the type to function. And so this is this reclassify function. Okay. So the helpers, there's different types of helpers. So we're going to use this function reclassify. And then the field that we want to reclassify is acres. Okay. And we're doing that for park size. Got an extra exclamation there. So I'm going to reclassify acres like this is shown here. So, okay, so these things are comments, all right? So they don't matter, but our definition is reclassify this argument of acres. If argument is none, return, I'm just going to return the value of none. Remember, this is a this is a string or it's text file. So everything we has to return has to be in single quotes because that's what's going to be entered in there. You can't just leave it outside. That is not a string. So I'm going to say then, so if argument is none, return none. Else if argument less than 5. So let's change this to less than 5. Then return, instead of what's here is 2, we want to return small. Okay. And then else if argument greater than equal to 5 and argument less than 20, return medium. Remember, single quote. And then else if argument greater than 20, the quote there, return large. So it's a large park. It's bigger than 20 acres. I guess I should have had greater than or equals to 20 because what if it's right on the value? Won't get anything. So let's put the greater than equal than 20. Return argument. Okay. Apply. Oh, something is missing or invalid. Argument is that reclass, def reclass, arg. Oh, after the 20, I was missing a colon. So you can always, okay. Now it should work. Okay, good, it did. Okay, so now we know which parks are large, medium, and small. If you want to sort ascending or descending, so large parks, mediums, and smalls. We've got a good distribution of those. Sarah Park is a large park. Community Park is a large park. Lakeside's large park. Okay, cool. So that worked. Okay. So then you can make this table comparing NDVI change by parks size. And you can also do it by areas that are not parks in Orem. And so how would you do that? Well, you could basically do kind of like an analysis of difference, right? Where we are not looking in parks, but where the rest of Orem. So you could kind of probably take Orem City and you could clip out where the parks are and then do zonal statistics to get the average value in that area and fill out this table. So to complete the steps, you'll want to select features by their size classification, calculate their mean statistics, and enter in the values, right? So if we select by attributes, and we say, let's make a new selection, new expression where park size is equal to large, say apply. Okay, and then for instance, you can say statistics then on NDVI, and you can see that the whole data set has average value. Where's mean? Sorry. Yeah, mean value of 0.169 for NDVI within all parks, but then within whatever I selected, was that large parks, it's 0.115. Okay, if I made a different selection, so I select the attributes and made a new selection, and I said park size is equal to small, and clicked apply. Then we see that the selection changes, right? The average NDVI in 2001 changes. Now we can change that to looking at 2022 or to difference, right, within here. And so you can actually get a lot of this data without a lot of clicks, right, to fill out this table. And the all parks is showing up in each case under data set. So that one's easy to fill out. And it shouldn't be changing each time we switch that small, medium, and large. But then the Orem not parks is another thing. Across the entire city where parks do not exist, you're gonna need to add this to your table. So you'll need to subset Orem City boundary by cutting out areas that are not parks. I suggest that you use the erase tool, and you probably did this in lab 4, generate a feature class called Orem not park. And then you can clip the NDVI data by your Orem not park feature class and then proceed, right? So you could even set up some sort of like model for that, but it's probably not necessary. So yeah, I could show you that, I guess, real quick. So if we go analysis, tools, I think it would be in here. Let's see, erase. Creates a feature class by overlapping it with an erase feature. Okay, so if we input Orem City and erase with Orem Parks, and we call the output Orem feature erase. Okay, it's made a mistake there because I had my some stuff selected. So, for instance, I can show you what I mean. Oh. It seems to have worked, I guess. I thought it didn't. Yeah. So I had some selected, but it did erase everything. So usually when you have something selected, it doesn't work quite like you thought. It only erase what's selected, but it doesn't seem like that is the case. Okay, so but nonetheless, I'm going to go ahead and clear my selection. So go back to map, clear. And so now I've got this Orem city, which is not the park areas, right? And then you can basically go back in and we could do some sort of batch process. So if we go to raster clip, actually, we don't even have to do that. Let's go back to zonal statistics as a table. And then the area that we want to look at is this Orem city erase. And we just need Orem city. And the input raster, well, we could do this as a batch. We can do it one at a time too. So we can look at the values of NDVI in 2001. So we're looking at the mean values. You could bring in all, but that doesn't matter because it's just one feature. And if we open that, we should just get a simple table. How many pixels were there, mean NDVI and Orem. I probably should have been clear that this was for 2001. So maybe I want to do that zonal statistics 2001, rerun it. So I'll remove that first one. And then could do it for 2022. So this is just putting it as a table for each one of these. And then we can do it for the difference, right? And then if we open each of those tables, should have the information that we need. And so in 2001, the mean NDVI was negative, just a little less than 0. In 2022, it's more positive. And the difference is actually, that makes sense. It would be generally even more positive. So 2022, Orem as a whole looks more green in terms of NDVI. So that's interesting result, right? So ask you to create a layout that helps aid your discussion of change in vegetation across all of Orem over the past 20 years. So to do this, you're going to need to figure out some custom labels, including the park's name, followed by a return, and the park size and acreage. And so you're going to use arcade language built into labeling of ArcGIS Pro. And so there's a little video tutorial on how to do that right there using something called text formatting.newline. And so I'm not going to make a video on that, but basically this is what you're expected to get out of this. That's going to basically show your somehow underlying NDVI difference values or something like, or values itself, and then show the park boundary over it. It's the name of the park, the class size, and the acres, and clip the acres to just a couple of decimal places so it doesn't look bizarre, and place it over the top of the difference map. Here's an example of the arcade code that I use to make that happen. Then after that, create a basic ArcGIS story map to describe and present all the things that I asked you to in this lab. And so, yeah, hopefully doing this potentially in a group might save you some time. Hopefully this video tutorial that I made here will help you proceed through it fairly rapidly. Let me know if you need help as we're in class.